Welcome to clickmyproject.com. Let's discuss about the product. Our product is optical flow estimation for flame detection in videos. Computational vision-based flame detection has drawn significant attention in the past decade, with camera surveillance systems becoming ubiquitous, whereas many discriminating features such as color, shape, textures, etc. have been employed in the literature. This paper proposes a set of motion features based on motion estimators. The key idea consists of exploiting the difference between the turbulent, fast fire motion and the structured rigid motion of other objects. Since classical optical flow methods do not model the characteristics of fire motion, for example, non-smoothness of motion, non-consistency of intensity, two optical flow methods are specially designed for the fire detection task, that is, optimal mass transport model fire with dynamic textures, while a data-driven optical flow schemes models saturated fire flames. Then characteristic features related to the flow magnitudes and the directions are computed from the flow fields to discriminate between fire and non-fire motion. The proposed features are tested on a large video database to demonstrate their practical usefulness. Moreover, a novel evaluation method is proposed by fire simulations that allow for a control environment to analyze parameter influences such as flame saturation, spatial resolution, frame rate, and random noise. Detecting the breakout of fire rapidly is vital for preventing of material damage and human casualties. This is a particularly serious problem in situations of congested automobile traffic, naval vessels, and heavy industry. Traditional point sensors detect heat or smoke particles and are quite successful for indoor fire detections. However, they cannot be applied for large open spaces, such as hangars, ships, or in forests. This paper presents a video detection approach geared towards these scenarios, where point sensors may fail. In addition to covering a wide viewing range, video cameras capture the data from which additional information can be extracted. For example, the precision, location, extent, and rate of growth. Surveillance cameras have recently become precisive, installed by governments and business for applications like license plate recognition and robbery deterrence. Reliable vision-based fire detection can facilely take advantage of the existing infrastructure and significantly contribute to public safety with little additional cost. So, as our scope of this process, design-based detection is computed in the following three steps. For example, initially pre-processing, future extraction. So, this is the flow diagram of our process. So, our process includes three steps. That means pre-processing. That is, it is necessary to compensate for the known source of variability, that is removal of noise, and then the future extraction, that is designed for the detection of specific target, a computational maps, raw data to a canonical set of parameters to categorize the target, and then classification algorithm. That means here we are using neural network as a classifier to classify whether it is fire identifier or not. So, these are our overview of our process. Let's see the demonstration of our product. As we earlier discussed, our product is based on MATLAB programming. For that we are using MATLAB programming tool. That is, here we are using MATLAB 2013A version for this implementation. So this is the main window of MATLAB. Here you can see a lot of small windows which are corresponding to particular desired work. So this is the command window. Here you can execute any command directly or indirectly, and this is the workspace. The temporary mat files like this will be visible here, so you can double click that and open and see the variables which usually in temporarily. So here the .m files are called MATLAB programming files. So .m files consist of programming files which corresponding to this flow estimation process. So here this are the functions, and these video files. These are the AVI files which can be used as the input, because here our video is based on the fire video. So our goal is to detect whether it is fire identifier or not by using neural network classification. So here initially I am selecting main file. So this is the main file. Here I am running the main file. So instead of this selecting run, you can press F9 through the main file. So here I have selected main file to execute the process. The whole process belongs to identifying the optical flow. So initially, to identify the optical flow estimation, we have to do some pre-processing. So in the pre-processing includes, as we already discussed, we have video as input. So the videos have to be splitted into number of frames. So from the converted frames we have to process. Here I am selecting the input video 004. The selected video file will be processed, and then the processed video file. So the processed video file is processing to convert into frames. So from the converter we have to process pre-processing. In the pre-processing it's doing filtering, and also our given RGB frames, that means color video, is converted into two-dimensional grayscale video. So because our optical flow estimation direction will be efficient for this kind of process, that means this kind of grayscale video process. So after this grayscale conversion, that grayscale converted files will be stored in a folder like the scalar frames. Here I am processing the flow identification. So for the converted grayscale video, our process applying. So here you can see the directions which identifying the flow of fire. So for the identified flow, we can see the gradient magnitude process. This shows only the fire pixels. Thank you.